In this video, I'm going to show you why sometimes for loops can be faster than while loops. At the end of the video, I'm going to show you a more practical example as to why in some scenarios you can avoid using loops altogether and use a different approach that may have a much faster runtime. And that depends on your situation and what you're trying to do. So if you find this video helpful, then be sure to give it a like and subscribe if you want to stay up to date with new videos that I post. So without further ado, on the screen you can see that we've got two functions here. So the first one, we just have a while loop and we increment I each time. And then it terminates once I reaches n. And n is this large number which is 100 million, I believe. Yeah, that's 100 million. And then we've got the same here with the for loop. However, this time the incrementation happens with the range function. And likewise, it doesn't do anything within the function. And it ends once I has reached 100 million. So if we were to run this, we'll see that in fact, the for loop takes 1.58 seconds and we're still waiting for the while loop. Yeah, so the while loop's complete. The while loop took 6 seconds. And you might be wondering, like, why on earth would they differ so much despite them basically doing the same thing? And the reason for that is because primarily, although Python is written in C, it is an interpreted language. So in the while loop, for example, we're doing these operations. So I is less than n and I plus equals 1. So we increment I here. And these are done in Python, which is interpreted. Whereas in the for loop, we're using the range function. And the range function is implemented in C, which is a much faster language than Python. And so we're doing the increment in C itself, which is why it's so much faster. I'm going to show you a second demo now. So this is slightly different. So we've got the same thing where we're using the range for the for loop. But you'll see that if we add... So in the while loop, here's the two comparisons we're doing, and then the increment we've got here. So two operations that are done in Python. And I've put those same two operations here in our for loop. And you'll see that this time, they'll be basically the same. So if you run the second one, so you see that the second one's completed running. And the for loop takes slightly longer this time. And you might be wondering, well, why is it taking slightly longer? And that's because we're actually doing a little bit extra than the while loop itself. So in the while loop, we've only got these two operations, the comparison and then the increment. So we've got the same comparison and increment here, but we're also incrementing I over here. So that's the slight difference. So in summary, essentially C is faster than Python. The range function is implemented in C, which is more efficient and is much faster than Python. And I'm going to show you a more interesting, more practical example. So we've got a while loop and a for loop here, but this time we're going to sum numbers from 1 to n. So you can see in the while loop we've got this other variable called total, and we return it. And what total is essentially total. We add I to it each time. So total is equal to 1 plus 2 plus 3 all the way up to n. And this is some very large number. And we do the same thing for the for loop as well. Down here, we do the exact same thing. But this time, of course, we're still using the range function. So we're going to expect the for loop to be faster than the while loop here. Now, I did mention at the beginning that there are some other ways that we could do this that could be much faster. Now, we have this numpy sum here. So we're using the numpy package in Python. And what this is doing is that it will do the same thing as the for loop and the while loop. It will add all the numbers together. However, this, we expect it to be faster because the numpy package is primarily written in C. So we'll be taking full advantage of that. And if you're wondering what this is, the reason why we have that there is because of integer overflow in C. So we need to have we need to store quite a large integer because we're summing all the numbers from 1 to 100 million. And then what this section here is doing, and this is one downside of using this method, is that we create an array of size n from 1 to 100 million. And that's what numpy does, and then it adds it all together using the sum function. And then our final method, if you can do this, this is the best thing to do. From a mathematical perspective, we know that 1 plus 2 plus so and so all the way up to n is the same as n multiplied by n plus 1 divided by 2. And that's just a mathematical formula. And the reason why this is what we would expect to be the best, even though it's written in Python, we're only doing one operation here, just one operation. And it's better than the numpy one since we're not creating an array of size n. So you might be wondering, so how different can these possibly be? And that's what we're going to run this time. So if I run that, so that's finally complete. And you can see that the mathematical sum using our formula here is significantly faster than everything else. So if you can use that, then definitely, you don't need to know the formula. You could possibly Google it. But if there is such a formula that exists for the kind of function that you're trying to create, then that's the best way to do it. If you can't do that, then you can try using some of the numpy functions, and you can see that's way, way faster than the for loop. So even though the for loop uses some C stuff in the range, we're still doing this operation here, which is quite slow. Whereas with the numpy one, we're using pretty much all of it is written in C, and it's been optimized really well. And if worse comes to worse and you can't use a for loop for whatever reason, then a while loop is your next best bet. But otherwise, this is kind of a comparison between sort of the different methods. I guess the title was, why are for loops faster than while loops? But then I think there's also these other potential ways of completing the same functionality, which you should also consider as well. Obviously, I'm recording at the same time, which is why these numbers might differ, and that this may seem a bit slower than if you were to try it at home. But I hope this was helpful, and if it was, then be sure to leave a comment. And if you have any questions, then feel free to ask or send a message. But thanks for watching.